Hello, this is Barry Evans with Penn State University. In Unit 8C, we will use MapShed to estimate the pollutant loads for a case study watershed located in central Pennsylvania. Specifically, we will estimate loads for the Big Hollow watershed that is a sub-watershed of the larger Spring Creek watershed. In terms of the specific activities to be completed, we will first open up MapShed and create a new project. We will then load the data layers for the area of interest. We will then select the watershed, that is the Big Hollow watershed, and initiate processing to create an input file for the GWLFE model. And finally, we will run the GWLFE model on the new input file to simulate pollutant loads for this particular watershed. For those interested in a quick review of these particular activities, they are covered in Units 3 through 6. Okay, let's get started. As you recall, a MapShed icon was placed on the screen as part of the original MapShed software installation. We double-click on this to open up MapShed. We will then build a new project, and we will call this Big Hollow, since that's the area that we will be working in. Type that in, say build, and at this point MapShed will open and present the following window. I will open this up completely, and then we can start using the different tools to load the data. So under MapShed Tools, we will first go to Load Data Layers, and we will load the appropriate data sets in this input form. And remember, for this particular exercise, we installed data, we downloaded and installed data in the statewide folder and the North Central folder, and we will be using different data sets from these folders to include in this form. First, let's load a polygons folder to represent the watershed. Now, we didn't really digitize a new watershed, but we can use the one that we did before under demo data. So under demo data, we can use Spring Creek, and then we can open this. We could also digitize a new watershed boundary if you want, and that's included in it. How to do this is included in an earlier exercise. After the basins polygon, we can then load the DEM, or Digital Elevation Model grid. Now in this case, it's not under demo data. We go to MapShed, and then to North Central. North Central is the folder that we loaded in a previous exercise, subunit in Unit 8. So we'll open this, and if you always lose track of what you're loading, in the top left corner here, it'll tell you what data set you want to load at that particular time. So we're going to go to the DEM data set. This is in NC, North Central, DEM 30. Double click on that. Double click on the NOCN North Central DEM, and remember, we always load the STA file for a grid. So we'll double click and load that. We'll follow that up with the land use grid. Now again, we go to North Central. In this case, we'll use the NC Land 2. Double click on that. North Central Land 2, double click on that, and again, load the STA file. Next, we'll load the soils polygon shapefile. Hit the Browse button. Now the soils is going to be located in the statewide folder. So we first browse to MapShed. Then we go to statewide. Double click on that. And we will load the soils shapefile right here. That is loaded. Again, remember, if you make a mistake, you can always hit the Browse button again. That clears the previous setting, and then we can load the correct one. Okay, let's now load the streams. Streams will be back in the North Central folder. So we go to North Central. North Central Streams. Next, we load weather data. The weather stations the shapefile that represents the weather stations will be located in the statewide folder. Again, we go back to MapShed. And then to statewide. And then load this one that says Weather Stay for weather stations. Now the directory, this browse button is going to ask us where the weather data are located. These weather data are located in Excel files in the statewide folder in the subfolder weather. Double click on that and we are presented with a whole list of STA files which are different weather stations. All we have to do is click on any one of these because this just sets the path for the weather data. So we click on any one and say open, and now the path to the weather folder is set. We will now load some of these other optional layers like the soil P grid, groundwater grid, and so forth, groundwater N grid. So we'll browse, in this case MapShed, go to North Central, NC Soil P, that's a Soil P grid, double click on that, North Central Soil P, double click on that again, and load the STA file. Remember, in Pennsylvania, this is always a soil test P. Soil test P and not total soil P. So you want to make sure that that's always set, which is set by default. Next, we load the groundwater nitrogen or groundwater N grid. Groundwater N, also in North Central, NC-GWN. Go to that folder, double click on the North Central GWN, and then load the STA file. Physiographic provinces. This will be located in the statewide folder. So we go to MapShed, and then to statewide. And again, we're looking for the physiographic provinces, and that is in something called PhysProv. Double click on that. Septic systems we will not load because in the newest version of MapShed we estimate septic system populations using the land use cover layer, so we do not load that. We will load a counties layer. Again, that's in statewide, something called county, open. We also have for the state and for the different regions an unpaved road layer. We can load that either from the statewide or from the North Central folder. They exist in both. It's probably better to use the regionalized version because it's a smaller shapefile. So we will load that. We will not use the water extraction, AFOs, or the flow line layer. Those are for something different. We will use what's called the urban areas grid, and I'll get into more detail on that in a later exercise, but that is an additional grid that shows the urban area boundaries within the different municipalities. So we hit the browse button, and again that's going to be in the North Central or any of the regional files, so it's NC Urb Areas. Double click on that, and again, and then we load that. That is a grid. And associated with that is going to be an urban areas lookup table, which is in comma separated variable format, basically a different text version of an Excel file. We load that by hitting the browse button, and that is under the NC Urb Areas folder, UA_LUT for lookup table. We do not load any point source data in this case, and at this point we can either do the check data layers or check layer alignment if we wish to, but since these are data sets that have already been prepared for Pennsylvania, we know that the files have been created correctly and that they are all in the right geographic projection. So we can at this point say OK, and we are asked if we want to save the changes, in this case the settings in a particular source file. We will say yes, and we could maybe I'll go to North Central. Actually, I'll go to MapShed, and we'll give it a source file name, and we will call it Big Hollow. This will be saved, in this case, under MapShed as a bighollow.src file, but you can really store this anywhere you'd like. I will hit the save, and as soon as I do that, data sets will begin to load into the MapShed display screen. Now, some of these will take a while because data sets that are loaded for the very first time, in particular grid files, have to be reformatted for display purposes. What I mean by that is a bitmap file or a .bmp file is created while it is loading the different grids. This only happens the very first time you load these data sets. Once you've done them once, it will not do that the second time you load the same file. So this will take a few minutes to load, and in fact, as you see at the bottom here, it says creating image representation of raster. In this case, it's the land use data set, so it is creating this bitmap file first, and this will take a few minutes to load. What I will probably do is edit this particular sequence so it skips to the very last step where all of the images are loaded. Okay, it is now about 5 minutes later, and as you can see, all of the different data sets have been loaded. Again, what happens with MapShed, and it's because of map window limitations, when you load very large data sets for the first time, in particular large grids like we have for some of the different regions within the state, an intermediate BMP file has to be created first, and these are quite large, and this is done for display purposes. Once these are created, however, they remain in the folder, and it does not take this long to reload these data sets for any subsequent session. So, now that all of the necessary data sets are loaded into MapShed, it's now possible to actually select a basin and start the processing to create an input file for the GWLFE model. However, before I do that, it may be useful to see the extent of some of the regional data sets that we've loaded into MapShed. For example, I'll turn on the stream layer, and using this tool, I can go to the full extent, and as you can see from this map, we've got an image of Pennsylvania, all the counties with the north central data set shown by the stream segments on the screen. I can turn those off. We also have a regional digital elevation data set. We've got the land use and so forth. Again, we're going to be focusing our attention on a subwatershed within the Spring Creek watershed. So I will go back to that particular layer and just zoom out here, and then I'll turn that off. Now, we are going to be creating an input file for this particular subwatershed here, the Big Hollow watershed, as discussed previously. If you'd like, you can actually add some labels using the ID field, as I'm doing here, to show the location of different subareas. Again, we're going to be looking at subarea 7238, which is the Big Hollow. Now, you don't have to have these things on in order to select a watershed, nor do you have to have any other data sets on in order to do the selection. So at this point, we go to this tool, Select Basin, as we've done in previous units. Select that watershed. Go to the next button here. It says Create GWLFE Input. This starts the processing to overlay these different GIS data sets and consider the weather data to create an input file for the model. So we click on that, For our purposes, we will use all of the weather years available, 75 through 94. We will indicate that the growing season is between May to September, which is pretty typical in Pennsylvania. We will not aggregate any basins. There's only one single basin, so that's the default here. Everything else we will set, we will use as a default septic system. We will use the land cover map to estimate populations on septic systems and so forth. So all we need to do at this point is to specify a model input file name, and we will call it, in this case, I'll just say Big Hollow. Now, if we leave this check on, it will create a new directory, a new folder called Big Hollow under the Run Files directory. If this is turned off, it will allow me to put this particular input file in any place on the computer. I can set up a new folder called Big Hollow or something else, and it doesn't have to be on the Run Files. It could be anywhere on your computer, but we will just do this automatically. So we will at this point, we'll create a file called Big Hollow, and the file name will also be called, the input file name will also be called Big Hollow, and will be placed inside the Big Hollow folder. When we're ready, we say OK, and this screen tells us the processing will take a while. Do you want to proceed? We will click on yes, and the processing has begun. Now, because of the large file sizes involved here with the regional data sets, this will take a little bit longer than the processing we did earlier with the demo data, which is cut to a much smaller area. Given that this will take a while, I am going to edit this sequence and begin again a few minutes later when this is complete. Okay, the MapShed processing is now complete. As you can see from the screen, it took just a little under 4 minutes. So we can click on OK, and we can now take a quick look at the input file. We can open up the GWLFE model, click on the input data button, and we will have a folder underneath Run Files called Big Hollow. We'll also have an input file name called Big Hollow with the watershed ID appended to the end, which is 7238. We can click on this. That is now loaded. We can look at the data if we wish. We will do this in a later section. Nutrient transport and so forth. So as you can see, the file has been created, all the values filled out, and all that remains to be done is to provide an input file or output file name and then run it. So we will call this maybe run 1 with the expectation that we might possibly edit the file later and rerun it. So we will say run. Upon running this, we are given this form that tells us that the model is complete. We can now again take a quick look at the output in either metric or English mode. I'll stick with metric. And now we can see that an output folder has been created underneath the Big Hollow folder. And this contains our output file from that simulation run that we had called Run 1. Highlight that and open it. And view the output. So here we have the hydrology, monthly load, loads by source, etc. And we took a look at some of this output information in a previous unit. We will do this again in the next unit. So at this time, this concludes our activities for Unit 8C, and we will now move on to Unit 8D.